Hello Klimani, welcome to today's maths video lesson. I hope you're keeping well, and hopefully this will be the last week of these video lessons and we can get back to regular lesson scheduling. I'm looking really forward to it, to seeing everyone again and not looking like a crazy person alone in my room teaching maths. So yeah, in today's lesson we'll just be going over the homework solutions for the work sent out for the second lesson of last week. And this was exercise 11 on page 135. I gave you 1F and 1I, 2A and 2B to do, but I'm also going to do 1B because you had some questions on that. So question 1B is asking us to sketch two graphs, one of them being a straight line y equals x minus 5, and the other is a hyperbola y equals 5 over x minus 5. In addition, we must show the intercepts and any turning points or asymptotes. So for these two graphs, the straight line and hyperbola, all we're going to be showing is intercepts and asymptotes. There's no turning points. Turning points only apply to parabolas. So let's get started. I just want to write down these functions. So it's 1b, y equals x minus 5, and y equals 5 over x minus 5. So I'm going to start off by drawing the hyperbola because the straight line is easy, and I'd rather do my more difficult graph first and then plot the easier one later. So I just want to make up some points to help me with this, but instead of doing the whole graph y equals 5x minus 5, what I'm going to do is plot points for the graph 5 over x. Okay, so once I've done that, I'm just going to shift the x-axis 5 up. Shifting the x-axis 5 up is the same as shifting the y values 5 down. So let me show you what I mean in a rough sketch. So say this was my graph for y equals x over 5. Now the minus 5 tells us we must move the whole graph 5 down. All the y values decrease by 5. So moving the y values 5 down and moving the x-axis 5 up does the same thing. So you can see now it's almost like we took these two branches and moved them down. Okay, so let me get some points, and I'm going to try and choose points that make my life a little bit easy. So I want some multiples of 5, so let's do x minus 20 minus 10 minus 5. Let's do minus 2.5. Okay, so when I put these values into our equation, it's going to be 5 divided by everything. So 5 divided by negative 20 is negative quarter, then negative half, negative 1, negative 2, and I mustn't forget the positive values. So I'm going to have 2.5, 5, 10, 20. And these values, these negatives are going to be mirrored for the positive x values. So I'm just going to write 2, 1, half, quarter. Now, before we continue, I just want to take a picture of these points. I'm going to rub them out and then plot the graph, and that's because of space issues here on this small board. So I want to draw the picture quite big and clear. Okay, so remember we said we're going to plot the graph of y equals 5 over x. So I'm going to do that on this set of axes, and then I'm going to move the x-axis 5 up. Okay, so the points I've got and the scale I've used are to try and help me so I don't get these difficult fractions to work out between these intervals. So the vertical intervals are going up in ones. So it goes 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, minus 5. And our horizontal intervals go up in fives. So 5, 10, 15, 20, and negative 5, negative 10, negative 15, negative 20. So I haven't filled in any labels because I've still got to move this axis up. So if you do a sketch like this, maybe in pencil, write down the values, and then you can rub them out and change them once you've moved the axis up. So, so let's plot. So I've got a positive 5 and 1. I've got 2.5 and 2. Then I've got 10.5 and 20.25. Then for the negative values, I've got negative 2.5, negative 2, negative 5, negative 1, negative 10, negative half, and negative 20, negative quarter. So my graph would look like this. On this side, and lastly we should include the point 1. So if we have x equals to 1, we have a value of 5, because 5 over 1 is 5. And our graph would look like this. Okay, so this is our y-axis. And you can see that this dotted line is actually our horizontal asymptote. So in this type of equation, when we looked at parameters, we saw that this minus 5 actually represents the horizontal asymptote, and it means that if we've shifted the whole graph down from our original set of axes, then we're also shifting the asymptote down with it. So our x-axis is here at the point 5, because we've moved the x-axis 5 up, or vice versa, we've moved the whole graph 5 down. So this is going to be our 0. This horizontal asymptote is at minus 5. And the equation for a horizontal line like this, because it's the y value being minus 5, the equation of this line is y equals minus 5. Okay, lastly, we've got an x-intercept. So if we continue on with this graph, let me just carry on a little bit. So if we look at this equation here, we don't need this one anymore. If we look at this equation, when we put the value of x equals 1, we get 5 over 5, which is 5, minus 5 is 0. So our point is x equals to 1 and y equals 0, and that's an x-intercept. If we were trying to work out the x-intercepts directly from the equation, you'd have to solve. So whenever we solve for an x-intercept, we make y equal to 0. So remember, y must be 0. So we get the equation 0 equals 5 over x minus 5. Therefore 5 equals 5 over x. Then we can times both sides by x, or we can flip both sides. I'm just going to times both sides by x. So 5 divided by x times x is 5, and 5 times x is 5x. And here we divide both sides by 5, so we get x equals 1. So once again, it corresponds to our coordinate point 1, 0. And lastly, we need to plot the straight line graph. Okay, so just before we do the plotting of the straight line graph, I just want to fill in my my x coordinates and y coordinates. So this is our origin 0, and I'm going up 1, 2, 3. And our x intervals are going to match the intervals we used there. So it's going to be 5, 10, 15, 20. And on this side, -5, -10, -15, -20. Okay, so our straight line graph has the equation y equals x minus 5. So the y-intercept is a value of -5, so I'm going to put a little dot there. And if we're trying to find our x-intercept, once again we make y 0. So then we get the equation 0 equals to x minus 5, therefore x equals 5, and the coordinate of our x-intercept is going to be an x value of 5 and a y value of 0. You can quickly check the value of 5. If you put 5 into this equation, we get 5 minus 5, which gives y equals 0. So remember, our scale is going up in 5s. So 0, 5 will be there, and then we just have to join the 2 points like this, and we're done. So now let's move on with the other questions. So now moving on to question 1f, we have to plot the graph y equals 2 to the power of x minus 2, so an exponential graph, and another straight line, y equals to 2 times x minus 2. And once again, we have to find any asymptotes or intercepts. So remember, for the exponential graph, there's no turning point. Turning point only applies to parabola. The exponential does have a horizontal asymptote, which we'll find here. So once again, let's start off with some points. And I'm going to once again start off with the exponential graph because it's the harder one. And I'm going to pick points that are going to make my plotting easier. So I'm going to start off with -2. -1, 0, 1, 2. Maybe let me include 3 as well. Okay, so we can do it like this. We can do 2 to the power of x first, and then we can do 2 to the power of x minus 2. And once we found all the y values for 2 to the x, for 2 to the x minus 2, we just subtract 2 from each of them. So 2 to the power of x is 1/4, then half, 1, 2, 4, 8. And now I subtract 2 from each, so I'm going to get -1 3/4, -1 1/2, -1, 0, 2, and 6. So I'm just going to take a quick picture of these points, and then I'm going to plot a nice big graph. So once again, here, if you like, you can plot the graph of 2 to the power of x, and then just move the x-axis 2 up, and that will relate to all the y points moving to down. So I'm going to actually do it like that because it chimes in with our first example. So I'm letting the x-axis be this dotted line, and my y-axis goes like this. And I don't actually have to make it I don't have to make it so low, because remember the exponential graph has positive values. So I'm actually going to redraw my x-axis here. And let's just check the points. So we've got -1, -2, 1, 2. And once again, I'm not going to fill anything in. I'll only fill in once I've moved the axis. And our y values go up to 8. So I'm going to go 2, 4, 6, 8. Okay, so you can draw like a little 8 in pencil. So we've got -2 and a quarter. So if this is going up in 2s, then halfway between is going to be 1. Halfway between that's going to be a half, and halfway between that's a quarter. So that's very close. Then we've got -1, a half, 0, 1, 1, 2, 2 and 4, and last point was 3 and 8. Okay, so our graph looks like this. Okay, so this was for the graph y equals 2 to the power of x, and for y equals 2 to the power of x minus 2, I'm going to shift the x-axis 2 up. Okay, so that corresponds to the y values decreasing by -2. So my new x-axis will be 2 up. Yeah, so it only goes up one interval because each of our intervals represent 2. So this is our x-axis, this is our origin at 0, and we can see now that our horizontal asymptote is the line y equals -2. And that's what we expect. For the exponential graph, this parameter is our horizontal asymptote. Okay, so now that we've plotted, we've got this is -2, and we can now make this point 2, 4, 6. And the x values are going to be the same. So this one is going to be 2. That's 2, yes. This one, sorry, it's 1. What am I saying? I'm getting confused here. So remember, these ones are going up in 1. So this first one is 1. Then we've got 2, 3. And on this side, we've got -1, -2. And then we're pretty much done. We just need the x-intercept now. We've already found the horizontal asymptote. So you can visually see that the intercept is at the point 1, 0. So you can check, if you put 2 to the power of 1, you get 2 minus 2 is 0. And then if you wanted to solve for the x value using the equation, then once again you would set y equal to 0. So we have 0 equals 2 to the power of x minus 2. So this gives us 2 equals 2 to the power of x. So at this point you could say 2 is the same as 2 to the power of 1. And when we're solving an exponential equation like this, we need the bases the same. Once the bases are the same, here they are, both 2 and 2, then we can just say that the exponents are equal. We can directly say that x must be 1. So that covers the exponential graph, and now I just need to do the straight line. So our straight line had the equation y equals 2x minus 2. So our y-intercept is at -2. Let's work out the x-intercept. So once again, we're going to set y equals to 0. So our equation is 0 equals 2x minus 2. And if we solve this, we get x must be 1. So our x-intercept is an x value of 1 and a y value of 0. So that's the only, those are the only two pieces of information we need for straight line graphs. We can have any 2 points. I'm just using the x and y intercepts because that's what this question is asking for. But you could pick anything. Say you could pick x equals to 3. And you could get a point somewhere there and plot the straight line that way. So let me actually do that, because with 2 points I might draw it a little bit skew. So for x equals 3 we get a value of 4, and yeah, our straight line does look good going through all these points. Okay, so we've spoken about everything, intercepts and asymptotes. So now let's move on to the next question. So 1J is our last question, and it's expected to be the toughest question in the section, and it's asking us to draw 2 parabolas. So the first one has the equation y equals x squared plus 3, and the other one goes y equals 2x squared plus 3. So these are not very difficult to plot, and I think the understanding here is, if you look at the difference between the two, there's a 2 coefficient in front of the x squared, and this question is maybe looking at how this coefficient affects the overall shape of the graph. So what we would expect is, because this coefficient is greater than the 1, that the second graph would rise more steeply. Its y values would overall be higher. And for the first graph, the arms would be wider. Okay, let's see if this pans out. So I'm going to choose some x values. -2, -1, 0, 1, 2. And then for the first graph, x squared plus 3, we have 2 squared, which is 4, plus 3 is 7. And then -1 is 4, 0 is 3, 1 is 4, and 2 is 7. So notice these points are mirrored, and they're mirrored about the y-axis. Okay, next graph, 2x squared plus 3. So if we plot -2, we get 4 times 2, which is 8, plus 3 is 11. -1, we get 5. For 0, we get 3 again. For 1, we get 5, and 2, 11. Okay, so I'm just going to quickly take a picture of these points, and then we'll get plotting. So our y values are fairly high. They go up to 11. So I'm going to go up in 2s, 2, 4, 6, 8, 10, 12. And for the x-axis, I'm just going to make my intervals for the 1, 0, 1, 2 a little bit wide. Okay, and this is just so that when I draw my graph, it's not, both of them aren't too narrow. So 0, 1, 2, -1, -2, and this goes up 10, 12. Okay, so our first graph was -2 and 7. So 6, 7 is midway. Then -1 and 4, 0 and 3, 1 and 4, 2 and 7. So our graph would look something like this. Okay, and like we said that this coefficient 2 is going to make our y values higher, and the arms will be more in. So let's plot that. We've got -2, 11, -1 and 5, then 0 and 3, 1 and 5, 2 and 11. And our graph does indeed go more inwards. Okay, don't forget the axis labels. And for the parabola, we don't have any asymptotes. So this graph just extends indefinitely this way and this way. We do have a y-intercept which corresponds to the turning point. And the turning point is at x equals to 0, y equals to 3, and that's the same as our y-intercept. Remember, the y-intercept is where x equals 0, so those 2 points are identical. So not really fitting off the hardest example in the section, but anyways, let's move on. Sorry, I've checked the homework that I gave out now, and it's not 2A and 2B, it's 2C and 2D. So this is a kind of question where they don't give values for the parameters. They just tell you whether these parameters are greater or less than 0. And some people will find them very easy because there's no plotting and no calculation. And some people would find it really tricky because they have to then try and imagine what the overall shape would look like from the very scant information. So let's look at the first question, 2C. We have information on a hyperbola, y equals a over x plus q. So these two parameter values are not given. All they tell us is that a must be negative and q must be negative. Okay, so we already know what the q parameter means for hyperbolas. It tells us our horizontal asymptote. So if I plot the xy axes, then in our standard graph, which goes like this, then our horizontal asymptote is the x-axis. With q being negative, our horizontal axis lies somewhere below that. Okay, and the other piece of information is that a is negative. So let's just look at that quickly. So based off our standard graph, y equals 1 over x, we have our two branches, one in the lower left and the other in the upper right. And now if we have the graph y equals to minus 1 over x, so we've made the a parameter negative. What this does is it keeps the y values the same, so all the heights are the same, but it makes the x values negative. So essentially it flips the graph about the y-axis. So it moves this branch and flips everything there, makes all the x values negative, and these x values for the lower branch are already negative. So when you make them negative, it flips them to positive. So in this case, the value, or the magnitude of A is 1. So if we increase A, our hyperbola is bowed more outwards. So say if A was 2, our hyperbola goes like that. And if A was less than 1, say A was a half, then our graph pulls more inwards. So overall, the shape isn't really affected. It's either being pushed more in or it's going more out. So this gives us everything we need to now plot the rough shape of this graph. So our vertical asymptote stays the same, and our branches must be drawn within the two asymptotes. So I'm going to draw the lower branch, sorry, it's negative. So it's been flipped about the y-axis. So our bottom branch is on this side, and our upper branch is now, sorry, we draw it within the asymptotes. And this should give us our overall shape. So lastly, for 2D, we have an exponential graph with some unknown parameters. And they give us that A is greater than 0. And I've just changed the second parameter B to be greater than 1. In the textbook, they have B is supposed to be greater than 0, but that's not specific enough. I'll show you why in a moment. And then Q is less than 0. So let me talk about what I mean by B greater than 1 and why B greater than 0 is not specific. So I'm going to choose two different bases which are both greater than 0. And I'm going to make up the graph y equals 2 to the power of x. So here B is 2, which is greater than 0. And next we're going to speak about y equals a half to the power of x. And here B is a half, which is also greater than 0. Now, if we play around with this equation, we know that a half is the same as 2 to the negative 1. So we get 2 to the negative 1 in brackets to the power of x. And now we use our distribution law for exponents and we multiply these two exponents, negative 1 times x. So it gives us 2 to the negative x. Okay, so I'm just going to rewrite that underneath. Y equals 2 to the negative x. Now let's consider the shapes of both of these graphs. So y equals 2 to the power of x, we are familiar with. It looks like this. Let me draw it a bit bigger. Looks something like this. X, y. And now the graph for y equals 2 to the power of minus x. Can you see it? It's actually a reflection of this graph about the y-axis. So remember, with y-axis reflections, we keep y the same. So the transformation from our normal coordinate point is we keep y the same and we make x negative. So that's what we're doing in this equation. We're changing the x from positive to negative and we're keeping y the same. So if we're reflecting this graph about the y-axis, we make all the x values negative while keeping y the same. So this one will be flipped here, this one will be flipped here, and we get the mirror image like this. Okay, so this creates a problem for us in this question. because b greater than 0 doesn't tell us if the graph goes like this, if it's a fraction, or if the graph goes like this, if it's a whole number. So I've corrected it and changed it to specifically b must be greater than 1. So b is some whole number, and I'm just going to use this type of shape. So the parameter a, being greater than 0, tells us that all the y values, or at least this portion, is going to be greater than 0. So the graph is upward sloping. If a was less than 0, we'd get a shape like this. Okay, so my normal shape is going to go like this, and if a was less than 0, it would be the bottom one. So now we pretty much have everything we need. So if we look for the y-intercept, and if we set x equals to 0 and put it into this equation, we get y equals to a b to the power of 0 plus q. And if we work this out, b to the power of 0 is 1, so we get y equals a plus q. So our y-intercept is 0, a plus q. And also our horizontal asymptote is given by the q, and that's less than 0. So that means our horizontal asymptote sits somewhere there. And our x-intercept, so our graph would do something like this. And when x equals 0, y equals to a plus q. So all we're doing is from the value q, we're going up a units. So this value here is a plus q for the y. And now we have everything we need. We can't really talk too much about any x-intercepts because there's too little information. So roughly the shape of our graph should go like this. Okay, so that concludes today's video lesson. I hope it made sense, and thank you for doing the homework and at least attempting the questions you didn't understand. And yeah, if you're struggling, you have my number. You're welcome to also email me. And yeah, thanks for watching. Have a good rest of the day.